Myself Rajendra Karale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about numericals based on enthalpy of reaction, enthalpy of formation, enthalpy of combustion and enthalpy of neutralisation. Now we are write down type 5. This type is not in the syllabus, though it is not in the syllabus, but it is also important for MBSE, CBSE, MHTCET, NEET and JEE. Now we are given the reaction CS2O gas plus O2 gas gives CO2 gas plus H2O gas. Here delta HR theta equal to minus 527 kilojoule. Now here how much heat will be evolved in the formation of 30 gram of CO2. Now here write down solution. Given data. Now here write down the given thermochemical equation is CS2O gas plus O2 gas gives CO2 gas plus H2O gas, and here delta HR theta equal to minus 5 to 7 kilojoule. Here to find heat evolved in the formation of gram of CO2 question mark. Now here let us observe the reaction. Here 1 mole of CO2 is formed, and when the 1 mole of CO2 is formed, heat evolved is equal to 527 kilojoule. That means here when 1 mole of CO2 is formed, evolved 527 kilojoule of heat. Now convert this 1 mole into molecular mass. That means here molecular mass of CO2 is, what is the atomic mass of carbon? 12. But how many carbon atoms are there? 1. That means 12 into 1 plus atomic mass of oxygen is 16. But there are 2 oxygen atoms and here 44 gram. That means 44 gram of CO2 means 1 mole. Now convert this line into the gram. Hence, when 44 gram of CO2 is formed, evolved 5 to 7 kilojoule of heat. Hence, when 1 gram of CO2 is formed, evolved 5 to 7 upon 44 kilojoule of heat, and hence when 30 gram of CO2 is formed, evolved 5 to 7 upon 44 into 30 kilojoule of heat. That means here when 30 gram of CO2 is formed, evolved 359.32 kilojoule of heat. Now this numerical is also solved using techniques. Now let us observe this reaction. Here this 1 mole of CO2 is formed and here heat evolved equal to 5 to 7 kilojoule. 1 mole means 44 gram. Heat evolved equal to 5 to 7 kilojoule, and hence for 30 gram heat evolved equal to 5 to 7 upon 44 into 30 kilojoule of heat. Now here write down Then write down next numerical. If for the reaction C solid plus twice H2 gas gives CH4 gas, here delta H equal to minus 74.90 kilojoule. How much? Heat would be liberated in the formation of gram of methane. Here answer is heat liberated equal to 187.25 kilojoule. Now try to solve this numerical in your home. That means this is for homework. You can also solve this numerical directly. Let us observe this reaction. Here 1 mole of methane is formed, and here heat liberated equal to 74.90 kilojoule. 1 mole of methane means 60 gram of methane. That means here heat liberated equal to 74.90 kilojoule, and find out for 40 gram. That means here heat liberated equal to 74.90 upon 16 into 40 kilojoule. Try to calculate this value. Now here write down type 6. Not in the syllabus. Though this is not in the syllabus, but it is also important for MBSE, CBSE, MHTCET, NEET and JEE. Now here write down numerical. The heat of combustion of methane is minus 891 kilojoule per mole. What is the enthalpy change in the combustion of 8 gram of methane. Now here write down solution. Given data. Now here the given thermochemical equation for the heat of combustion of methane is, heat of combustion of methane means 1 mole of methane gas is completely burned in the excess of oxygen or air. That means here CH4 gas plus dash dash dash, this carbon is converted into CO2 gas, but here there is only one carbon atom. Here write down 1 CO2 plus hydrogen is converted into water, but there are 4 hydrogen atoms, so here write down twice. Here comma delta SC theta equal to minus 891 kilojoule per mole. Now here to find enthalpy change in the combustion of 8 gram of methane. Now from this thermochemical equation, it is clear that when 1 mole of CH4 is completely burned, then enthalpy change is minus 891 kilojoule per mole. Now convert this 1 mole into gram. For this purpose, let us find out the molecular mass of methane. That means here molecular mass of CH4 is M equal to, what is the atomic mass of carbon? 12. But there is only one carbon, that is 12 into 1. Atomic mass of hydrogen is 1, and there are 4 hydrogen atoms, and here that is 16 gram, and which is nothing but the 1 mole. That means here convert this mole equal to gram. 1 mole of methane means how many gram? 16 gram. when 16 gram of CH4 is completely burned, then enthalpy change is minus 891 kilojoule. Hence, when 1 gram of methane is completely burned, then enthalpy change is minus 891 upon 16 kilojoule, and when 8 gram of methane is completely burned, then enthalpy change that means here when 8 gram of CH4 is completely burned, then enthalpy change is minus 445.5 kilojoule. Now, the same numerical can also be solved shortly or directly. Here the heat of combustion of methane is given. That means here 1 mole of methane is burned. Enthalpy change is minus 891 kilojoule. 1 mole of methane means 16 gram. That means for 16 gram minus 891 kilojoule, and hence for 8 gram delta H equal to minus 891 upon 16 into 8 kilojoule. That means in this way you can also find out the answer directly. Now here write down next numerical. Heat of combustion of carbon to carbon dioxide is minus 395.8 kilojoule per mole. Calculate the amount of heat liberated when 0.8 into 10 to the power minus 2 kilogram of carbon are oxidized fully. Now here answer is heat liberated equal to 593.7 kilojoules. Now try to solve this numerical in your home. That means this is for homework. Now the same numerical can also be solved directly. Heat of combustion of carbon to carbon dioxide is given. That means here 1 mole of carbon on complete combustion, heat liberated equal to 395.8 kilojoule. 1 mole of carbon means how many gram? 12 gram. Heat liberated equal to 395.8 kilojoule. Now this much as the kilogram, that is 18 into 10 to the power minus 3 kilogram. Convert it into gram, which is equal to 18 gram. That means here 18 gram heat liberated equal to 395.8 upon 12 into 18 kilojoule. Try to solve that answer. Now here write down type 7. This is not in the syllabus, but this is also important for Maharashtra Board of Secondary Education, Central Board of Secondary Education, MSc, CET, NEET and JEE. Now here write down numerical. Heat of neutralisation of SCMH minus 57.32 kilojoule. Now what is the enthalpy change in the neutralization of 0.1095 kilogram of HCl in dilute solution. Now here atomic mass of H equal to 1 and Cl equal to 35.5. Here write down solution given data. Heat of neutralization of HCl is given. Now apply the definition of heat of neutralization here. Enthalpy change when 1 mole of H plus ions from an acid are neutralized by base, or enthalpy change when 1 gram equivalent of acid is neutralized by base. Now here the given thermochemical equation for the heat of neutralization of HCl is, that means here HClAq plus NaOHAQ gives NaClAq plus H2O liquid, and here delta H and theta is equal to minus 57.32 kilojoule. Now we are to find enthalpy change in the neutralization of 0.1095 kilogram of HCl. Now let us apply the definition. When 1 gram equivalent of HCl is neutralized, then enthalpy change is minus 57.32 kilojoule. Now convert this 1 gram equivalent of HCl into gram. 1 gram equivalent means equivalent mass expressed in gram. Now in order to calculate equivalent mass, first calculate the molecular mass of HCl is. What is the atomic mass of hydrogen? 1. But there is only one hydrogen, that is 1 into 1 plus atomic mass of chlorine is 35.5 into 1, because there is only one chlorine atom. That means your answer is 36.5 gram. Now calculate the equivalent mass. Equivalent mass is equal to molecular mass upon basicity. That means 36.5 upon 1, because one hydrogen atom is there, and hence which is equal to 36.5 gram, and which is nothing but the 1 gram equivalent. That means here 1 gram equivalent of HCl means 36.5 gram of HCl. Now here then 36.5 gram of HCl is neutralized, then enthalpy change is minus 57.32 kilojoule. When 1 gram of HCl is neutralized, then enthalpy change is minus 57.32 upon 36.5 kilojoule. When 109.5 gram of HCl is neutralized, then enthalpy change is minus 57.32 upon 36.5 into 109.5 kilojoule. That means here mass of HCl is given in kilogram, convert it into gram by multiplying 10 to the power 3. That means when 1095 gram of HCl is neutralized, then enthalpy change is minus 171.96 kilojoule. Now the same numerical can also be solved with the help of techniques or directly. Here heat of neutralization of HCl is minus 57.32. That means when 1 gram equivalent of HCl is neutralized, enthalpy change is minus 57.32 kilojoule. 1 gram equivalent of HCl means 36.5 gram. Here delta H, and hence for delta H equal to minus 57.32 upon 36.5 into 109.5 kilojoule. Now here write down heat of neutralization of KOH is minus 57.32 kilojoule. What is the enthalpy change in the neutralization of (1.12 into 10 to the power minus 2 kilogram of KOH in dilute solution. Now here enthalpy change equal to minus 11.26 kilojoule. Now try to solve this numerical in your home. That means this is for homework. Now you can also solve this numerical directly, which is very helpful for the entrance exam. Heat of neutralization of KOH is given. That means whenever 1 gram equivalent of KOH is neutralized, enthalpy change is minus 57.32 kilojoule. One gram equivalent of KOH means atomic mass of potassium is 39, here 16 and here 1, total 56. that means 56 gram of KOH is neutralized, enthalpy change is minus 57.32 kilojoule, and henceforth now convert this kilogram into gram. That means for this purpose multiply by 10 to the power 3. Here this becomes 11.2 gram. That means 11.2 gram delta H equal to minus 57.32 upon 56 into 11.2 kilojoule. Now this is regarding about numerical based on enthalpy of reaction, enthalpy of formation, enthalpy of combustion, and enthalpy of neutralization. Remaining part of this chapter unit will be discussed in the next lecture.